All right. A couple classes ago, let me do it that way, I guess 2 or 3 classes ago, wanted to glue together the relationship between the primary focus of the business analyst and the development team. We've done this little kind of sandwich diagram, let me call it. The BA does requirements and the BA does database requirements, data requirements technically. And then in red, I put in the development, what the development's doing. So let's review that over in our mind so we get oriented towards that, because we're in this mode of working requirements in a fashion where we're communicating with the solution architects. We went through use cases and use case diagram on Monday. And that's discussion context, usually with the business people, but for obvious reasons, it's applicable to the development team as well. Okay, so as we keep marching down this path of working with the development team, let's go back to our summary diagram. All right. So the summary diagram at the top level I mentioned was BA. BA is doing requirements. So what are the 2 forms that requirements take? High level.
Business requirements. PRD.
Right. Go conceptual, high level. So you're correct. Both answers are correct. But let's raise it up a notch. Looking at the 10,000 foot view.
Strategies.
There is strategies that go into the area requirements. Actually into the area portfolio, which puts together the business case, which then results in a project charter. So 2 types of requirements at the very, very high level.
Oh, functional and non-functional.
We're going to be hitting on that one. So
Let's go.
Okay, those still tend to be within one of the categories. All right, so the types of requirements. We've got the 2, 3, and requirements is equivalent to scope. One about right here is where the solution requirements go. And then as Mark mentioned, we've got the functional requirements. And the non-functional requirements here. Non-functional meaning numeric. Okay, super high level law.
The investment space. Processes.
Higher than that. There's only 2 categories of requirements. So this thing at the very, very top level, there's only 2 categories of expressing requirements. Let me call that word expressing requirements. There's textual and
Oh, okay. Diagram.
right, exactly. So there's textual, and then there's also diagrams. Okay, those are the 2 ways of expressing diagrams.
Yeah.
Or sorry, expressing requirements. So the different types of diagrams we've worked with is like swim lane, use case model. Not civic so much, you could argue that that's textual, but the value stream mapping, it's another way of diagramming. We looked at interface, we looked at what did we look at the end of Monday that would fit under this diagram space. So it was that right after we got done with our use case diagram and use case presentation, we looked at another set of techniques. We didn't spend a lot of time on it. It was only 20 minutes. So this is just to review the stuff that we covered 48 hours ago.
I blanked out everything.
You can look at your notes, it's all right. Look it up, so as you think through it, then it sticks. I don't want to give you the answers because you've got to prompt you.
But that's why my mind is blank on the PhD.
Right.
Understood.
So you're focusing on the exam yesterday.
Yeah, I know, so I don't remember the PhD stuff.
All right.
My
Was that-
excuse. I have an excuse.
Rather than I want to. But what, in one of the slides, we had this diagram that kind of went like this. There was a label here, a label here, a label here, a label here, and a label here.
Context diagram.
Yeah, the middle one here was context diagrams. So what is a
Data
context?
flow diagram.
There we go. So there's context diagram, data flow diagram. All right, which one has levels?
Context diagram.
What's that?
I was gonna say 50-50 shot.
Right, yeah, 50-50 shot. I didn't hear your answer though.
Data flow.
Yeah, you're right. Right, because this one has the levels where you can drill in and see different decompositions from a high-level process down to something more atomic that is closer to what would actually be converted into software programming code, software code. Okay, at the high level, you don't have something that can be coded. You got to get down closer to the bottom where the algorithmic nature of the code would exist. And once your circles are equivalent to 1 or 2 or 3 algorithms at the most, then you're at a low enough level.
Right.
Right. So that this idea of leveling within the data flow diagram is critical for it to be operational. So when we're introducing the data flow diagram, Mark had a question about, okay, so how do you actually keep track of all this stuff? There's another item that goes along with the data flow diagram. And what is that? It's considered part of the techniques. It's in the VA box. I forgot to pull up the book last week, or on Monday when I had it with me. Last page of the slides for the data flow diagrams. This is a VA box book. So all these techniques are in here. If you wanted to take a page through that at some time, go ahead. Pass it around the room as you go. You know, and it's alright if somebody has it for like a half hour, pass it around slowly. All right, so there's data flow diagram and there's data
Dictionary.
data dictionary.
Okay. Slide 2.4.
And leveling requires there to be a data dictionary because the labels on the arrows between the processes are labels. So what the process is the circles, the arrow from one process to another process represents what? It represents direction.
Association.
Now think back to SIPOC a little bit, just to borrow that example. It's not a perfect analogy. You got SIPC is based around what? I can put it up here. What does the acronym stand for?
Suppliers,
Process.
This right here, the input and output. That is, when I have a process where I'm going like this and I'm putting some type of label on the arrow, I'm going from process 1 to process 2. What is that arrow indicating relative to SIPOC? Borrowing the concept of SIPOC. SIPOC is business process oriented. So you don't use the SIPOC for describing software design. You use SIPOC for describing business process. But we use the word process when we're talking about business workflow, and we use the word process with a different definition when talking about software design.
It's an interface.
What's that?
An interface.
interface analysis.
So label on here, it's the interface technically is this portion right here. You know, it's like, what method am I calling it inside this other process, inside the code?
With the arrow, you see which process produces an input, uses an input, and which process produces an output.
Exactly. So here's the output right here. And the input is this little juncture.
Yeah.
So I've got input going into process 2, which is output from process 1. Okay. So in the business workflow context, I got input into the process and output from that process to some type of customer. So obviously there's always some type of trigger that's going to give me some input. So I can have a flow like this, but there's still always some type of trigger. So if this is my this is my system, what do I got? So this is the input. So what's generating the output right here?
Another process.
This is
Another user.
It'd be another process, but if I make this be only what I'm focusing on, how do you diagrammatically represent that item that's providing me that is provided an output that becomes an input to process 1, right? Square, external.
Oh, okay.
Okay, so there's some external system. You can almost think of it as an actor, so to speak.
Right.
Technically, it's perfectly fine to think of those rectangles that we saw in the data flow diagram as being an actor.
Yeah.
They're external to the system. Okay. So they're generating some sort of output, goes that process, and this process can kick back and say, okay, here's an output from me to you. So, this is a very realistic scenario, right? You get the trigger from the external, causes some action inside a system. The system pushes that down to do further processing, doing whatever calls might be necessary. And let's see. And then kicks back. I need to draw way down here. So let me do it way up here. It kicks back some type of output here, comes an input there, gets fed back. All right, so just a typical closed loop, go off and do something, come back. All right, the external agent or actor is sending in some input stream, passes off to process 2. Process 2 does its processing, process 1 returns it back. So very simple, but whenever we talk about data dictionary, what is the data dictionary encompassing with regard to the diagram? What's the data dictionary encompassing or focusing on with regard to the data flow diagram? All right, that's actually a good distinction. It could involve the values being passed at the very lowest level of definition. But it would normally be the label on the arrow. If you want to find out, every one of these is going to have a label that's unique.
Yeah.
Okay. So all of these labels, which is the data that's being pushed, from one point to another point, it's all the input IO for short, all the input-output labels. So I can have a bundle where I just say, okay, this is point of interest data, and then I can say point of interest data encompasses museums, restaurants, and hotels. And within the data dictionary, then I could have another entry that says, okay, I've got museums. So this is what the nature of the data is for museums. It's the location and the type of museum. I get another entry in the data dictionary that says this is the restaurant, and the type of restaurant and the approximate cost. I mean, we expect to see that kind of information on our location app whenever we're interacting with a GIS system that we showed in the context diagram.
Yeah.
All right, so I can break that down in terms of location. So point of interest locations would be the top level, and then break it down and you'll see further details. And so there's levels. So context diagram just shows the system as one circle, and then all of the rectangles around it are the external. So the key thing here is this is level the data flow diagram. It has multiple processes. And this is from a software design perspective, system design perspective, depending on how high level you are. This has just one circle, which is our system of interest that we're focusing the requirements on. And this, say, equals the system from our perspective. It's a context diagram, data flow diagram, data dictionary. Those all go hand in hand with each other. So we had looked at one other table. It was a rather complex table, but when we tore it apart a little bit and focused on interfaces, it was just identifying, okay, for these external flows to the processes, we've got bulk data, we've got stream data, we've got latency. So there's this interface specification concept. So the context diagram is gives us, to overuse the word context, it gives us the context from which we can then do an interface specification. So we got interface specification here. I don't remember what we had up here. This is context diagram. And this was data flow. And from a categorical perspective, data flow involves the context diagram. Make that squeeze in here. Somebody go to that chart. Which one am I
This isn't
missing?
comparing anything like that.
Yeah.
68.
Yeah, we'll take a look at that. Open
Not getting the-
So when we talk about a level and the data flow diagram, what's the level referring to there? That a delta to which?
Let me answer that by bringing up this slide here. All right, there we go. All right, so we had this to begin with. Let me make sure I'm sharing properly. Yeah. Okay, so.
You just give me.
Get out here so I can see page numbers. Right, it's on page 240, starting from there.
Yeah.
Okay. So look at the topic of interface analysis involves using context diagrams and interface specification. Okay. So this is what we looked at in the last 20 minutes of the class. We're just doing a rehash on this a little bit. And we, from a BA Bach perspective, even though it looks a little weird in this the circle or ellipse that's on the right, say data flow diagram twice. That's not really the way they print it in their book. So I just left it that way. So there's a category of interface analysis that involves context diagrams, interface specifications. The category of data flow diagrams also uses context diagrams for the purpose of constructing data flow diagrams. So it's kind of double worded, double labeling, but that's the way they put it in the book. I think they put it in there once, but that's all right.
So if you look at slide 168, it doesn't look anything like that. And since it's a context diagram, I'm confused.
So this is conceptually how the diagrams relate to each other. So we're on which page?
168.
No, I mean,
Yeah, I was at
241.
241. You're showing that on the board, but this says this is an example kind of, and it doesn't look like that. I don't like inconsistencies.
242.
One
There's always-
consistency.
There's always two or three different formats for representing things. It took like 25 years for object-oriented development methodologies and representation to merge into one standard called UML. There's not one standard for context diagrams. There's about two or three different contexts for.
The kind of those what is depicted here on the board. Does it not?
Yeah, this one does.
No. So this
Well, I mean, the outsides are squares, but,
and.
I mean, yeah, all this has labels, but we don't show big circles inside.
Right.
That's all.
Right.
But it's just, I was like, wait, something else looked different.
Don't you see the haze?
So on page,
Yeah.
so let's go to those two side by side, but let me get to the first one with the GIS system.
I mean, I can see the
And then we'll go
labels,
back
I
to
can
that.
see the external squares, but their internal, there,
There's no circle in there.
there's no circle. And the
That's a
internal
pattern.
processes are squares, not circles.
So let's take a look at this. All right, so this is the Gain-Sarson notation. So what Pat is referencing off on a different page, which we'll look at in a moment, is a different notation. All right, so this one says, make it really clear which system you're focusing on.
Yeah.
Okay. And we looked at this, so this is a context diagram where the entire geometric information system is at the center, and the app on our phone is called the advisor. And then there's a lot of other information feeds going into the GIS system.
Right.
So this is literally what powers our app that we take for granted. So there's lots of interfaces going on here.
And that is still using the Jim Dawson notation form concept basically.
Exactly.
With things are external being represented in rectangles, or squares, the inside being, or the process, which is the inside being represented in circle.
Correct.
Yeah.
Okay, so this is an exact representation of that previous
Here it
format.
says example data context, data flow context diagram. I thought we had context diagram and data flow diagram, not the mixture of the two.
You use the context diagram to create your data flow diagrams and to do the interface analysis. So technically, these are all data flows right here between the external entities and the system. Okay, so if somebody says, oh, show me the data flow context diagram or show me the context diagram, it's the same thing. Because the context diagram is all data flows. It's just that it's taking the entire system and planting it in the middle and showing everything around it.
And the simply data flow diagram is a diagram that includes the inside of the system.
Right. When we get to this point, now we're looking at the inside of the system. So this is Jordan. He's another guy that put together notation format. It's very similar to the Sane Gerritsen, or Gain-Sarson here. You know, input data, output data, just shows closed loop. This is essentially what I drew on the whiteboard a few minutes back. Okay, so visual snapshot and go to this. Here, this is showing input data coming into a system and then output data going out. There's no reason why I can't have an output going to an external agent here as well. Okay, so the only difference between this and the Gain-Sarson is that Jordan says, hey, let's be a little bit more elaborate about this.
Yeah.
Let's show what's inside the circle.
Yeah.
Okay, so this is where you get some variation, and this is where you actually have data flow. Now, as somebody had asked about leveling or made a comment on that. So that my rule of thumb was that if I'm showing how, let's think of one of the projects we're doing. The translation one comes to mind more than anything else right now. Okay, so say here we've got software to support translation in a very broad sense to support translation. So one of these external agents could be a a trigger that involves adding a translator. So there's a certain approval process that has to be verified, and so that you're ensured that the translator has the right credentials. Maybe there's like, okay, give me your certifications or whatever, take this test, exam, whatever. Right, so I could take that as a process and just say, I'm going to support the artifact or evidential collection to that is the record for confirming that this translator is valid for what that person claims of his or her abilities. So then that's just it. It goes right into the data store. Period. Done. But when you drill inside of this, just gather credentials and evidential. If I go inside that, there's going to be a state machine inside here. It's like, okay, nominate persons nominated, persons in review. Review meaning collecting records. Actually, that would be next, and then there'd be in review and then approved.
Right.
So there'd have to be, from a software perspective, there's going to be some more processing that happens underneath the hood. Now, if you look at the actual translation, I could just take this as being initiate translation, initiate/perform translation, and publish translation. So that's still way too high level to actually write any code against. I'd have to drill into each of these and provide more information about, okay, what does that actually entail? Because I'm the developer and this is all you gave me. I can't write any code for you. Unless you want me to make a whole bunch of assumptions. You know, if it's existing code that everybody's familiar with already, this actually might be sufficient. But if it's new code, there's no way this is close to sufficient.
Yeah, but it seems in reality there will be an arrow also coming out of the data store to the data process.
Yeah, there should be something reading this thing.
Right, yeah.
So, you know, I would put a read arrow in here. Because taking the example that I mentioned,
Yeah.
where you have a translator who's got credentials, you have to now take a document that's going to be translated, and there has to be some like cross-check.
Right.
We read the data store to see that the proposed translator actually has the right credentials for the language in which this document, the source of this document is written.
Yeah.
So that's a good point. You know, having a read coming out of the data store to this upper
Right.
data process would be good.
Or it could go to that other data process.
It could go to the other one too, but in the example that I gave, it wouldn't make sense necessarily. So I think I might actually take this and do the next version with the example.
One thing I really love about doing this class here is there's a lot of people with a lot of background and experience. So
If you're redoing this, I would suggest for most of these, a table of contents would be very handy at the beginning. I know you would have to update it every time you stuck a slide in there. I understand that.
Right.
It makes it a pain in the butt, but it would be helpful. I know.
totally agree. I never had that convenience in any class I've ever taken in the last 25 years though, so.
You're one of
we'll stay with the
so you're following the, I had to go through the residency thing and work 45 hours straight.
Right.
You have to. I like that. Yeah, the federal government finally stopped that now.
Every course I ever took like this, I always created my own index as I went through it. By the time I was done with the course, I had an index. Or a table. I didn't go to the table of contents. I wanted more detail than a table of contents.
All right, so data flow diagrams in here. Let's see. Source and sink, those are, in other words, that are present. Data stores you saw. The term data dictionary is what shows up here. On the last side, so data dictionary is just verbally what I mentioned to you in the example of the GIS, where you have point of interest information. They could be like 3 categories: hotel, restaurant, museums. And if I just take and broke down those 3 categories, each of those categories have different entities or different attributes. So what's interesting here as I just said that, now something should trigger in your mind. Oh, I've heard that before. The data dictionary, when you get to the innermost parts of the bundle, it's entities and attributes. That's all it actually is entities and attributes. So in what context have we seen entities and attributes already?
Entity relationship.
The entity relationship diagram. So at the end of the day, you're going to store something, but in the context of a data flow diagram, it's immaterial. It's not relevant, in other words, whether I'm actually storing something or not, unless I'm writing to the data store. So when I go back to this transformed output data, this is literally the entity and the attributes that we identified in ERD diagram. It's getting written into the data store. Okay, so just so we tie together concepts, because everything is pretty much related here.